All right, so in the first unit, we studied what happens if you have a single force acting on an object. Now, what happens if you have more than one? Right? Because in the end, right, what we're looking for in mechanics is how forces can cause objects to move. And if we have to limit ourselves to a single force, life is not going to get very interesting. All right, so let's quickly recap. Right? We already saw Newton's first and second law. If there's no force on an object, the velocity will remain the same. And if there is a force, then the object will experience a proportional change. Now, there's also a third law that tells us something profound about multiple objects and multiple forces. And it says, if I push you, you push back. Equal force, opposite direction. Or slightly more formally, if object A pushes object B exerts an equal but opposite force on object A. Right? Often abbreviated as action is minus reaction, but don't forget that the action and reaction forces act on different objects. Right? So let me illustrate. Right? Here's a block, and gravity is acting on it. There's a book. Gravity is also acting on this. But if I put the block on top of the book, right, gravity is not going to accelerate it. The book is going to be stable because I'm supporting it with my hand. Right? So my hand is exerting a force on the book, and the book is exerting an equal and opposite force on my hand, and so everything stays in place. And the same goes for the block on the book. Right? So we can draw this in a cartoon of the book and the block, or anything. Right? On the block there's a force of gravity pointing down, and there's the force of the book, or the table, or whatever it's resting on, pointing up. This reaction force from the table or any object that's on any surface that's supporting you is known as the normal force. And it's called normal because it's always normal to the surface, meaning perpendicular to the surface from which it's acting. Now, this is still a rather, say, one-dimensional situation. But we can very easily make it multidimensional by simply tilting the book. Right? Now, the force of gravity is still pointing down, but the normal force is no longer pointing up because perpendicular to the surface is now under some angle. So if we want to know how big the normal force is, that's only the component of gravity that's pointing towards the surface. So we have to decompose the gravitational force and find the component that's perpendicular to the surface, and that will give a reaction force, which is the normal force. Right? Decomposing this is using just basic trigonometry. There's a simple trick to remember whether you need the sine or the cosine. Just turn it back in your head to the vertical position or the standard position. If the force goes away, it was the sine. If it doesn't go away, it was the cosine. Because the cosine of 0 is 1, and the sine of 0 is 0. All right, so the y component, right, the component of the gravitational force on the block that's going perpendicular to the book goes with the sine, and the x component goes with the cosine. Now, if I tilt the book a little bit, the block will still stay in place. Right? So there must also be a force that compensates for the gravitational component along the surface of the book. And that, of course, is friction. So when do you get friction? Well, best known example, perhaps, is if you have cold hands and you rub them together. Right? There's friction between your hands because of two reasons. One is that you're pushing your hands together. If you're just moving like that, there's no friction. And the other is because you're actually moving. Right? So friction emerges when you have two surfaces, for instance the block and the book, that are exerting a force on each other. In this case, the normal force of the book on the block and the gravitational force that's causing the block push on the book. Right? And they are either already moving or about to get moving. That gives you a friction force. Right? So right now there's no friction force because it's not about to get moving, but if I tilt the book, if there were no friction, the block would start moving. And the more I tilt, the larger the x component of the force becomes, so the larger the reaction force of friction becomes. Up to some point, if I tilt the book too much, this thing will slide. And that's because the friction force becomes less at that point, because the normal forces become less. Right? So frictional forces are forces that are changing. Right? If I say plot the friction force on the block as a function of time, and I start horizontally, now it's 0, it's increasing, and if I twist at a constant angle, it will increase linearly up to some maximum value. Right? And this maximum value is some force factor times the normal force. And then beyond that, when it's moving, it will just be this constant factor times the normal force and be sliding down. All right, so that's for a book and a block. Now that's a bit of an artificial situation, right? How often do you find yourself studying Lego blocks and soft matter physics books? But right, in everyday life, this happens all the time. Right? This woman climbing the rock or abseiling from the rock is actually using this to make sure that she doesn't fall down. Right? She has, and to study this, we can also make a cartoon of that. Right? So I'm going to draw her body as a simple square block or rectangular block. I'm going to draw the rope as a simple line. And so we have, what do we have? We have the force of gravity pulling down. We have a tension force in the rope. And we have, which hopefully balances the force of gravity, right? So the component of the tension force that's vertical should balance the component of the gravitational force that's pulling it down. And then, of course, this also gives us a component of the force that's into the rock. And the rock is pushing back with a normal force on her feet. And if all of these are exactly in balance, then there is no net force and there will be no acceleration. So she can slide down at constant speed. Or if she imbalances it a little bit, she can accelerate down or maybe climb on up. All right, so that's about forces. Of course, we get to practice with that. In the next unit, we're going to see what an effect of force, because if you're exerting a force and you're moving, you're doing something called work.